Okay. All right. Okay. I'm going to send you something on the Zoom chat. That's the programming language thing. So the reason why I use this programming language is because it runs on the web browser. So you don't have to install anything.
All right,
Uh,
cool.
okay. I've just sent it to you on Zoom chat. If you could open that and then share your screen with me, that would be great.
Okay, hold on. Now I do have to let you know my computer is kind of a potato, so if it doesn't, screen share the best, I do apologize.
It's okay.
All right. Hold on, I just gotta find where to screen share. All right, it seems like it's loading in. Can you see my screen all right?
I can see it loading. 1 second.
Okay. Oh, what is this? Okay, I think it's all put together now.
Okay. Yeah, I can see it now. Okay. All right. Okay. I also saw that you have some prior experience, but you forgot them all. Was that
Yeah.
accurate? Okay. So I
Mm-hmm.
don't know if the pace is going to be good for you. This might be too slow because I find that like for people with like prior experience, even though it was like many years ago, it like it's resurfaces like it's a sleeper agent. But if
Mm-hmm.
it's too slow, just let me know and we can pick up the pace.
Okay.
Okay. All right. Let's get started. All right. So I would like you to first think of two big numbers,
Two big numbers. Okay.
and I'd like you
Like
to
how
add
big are we
them.
talking? Like doubles or triples?
Uh, Big enough where you can't calculate it in your head, but small enough where you can write it down quickly.
Okay. All
So I'd
right,
like you
I've
to
got
think of two big numbers, and then I'd like you to add them.
Okay, two big numbers and then add them.
Yep.
Okay. Should I do that like on the programming
Oh, yes. Yep.
okay, because yeah, all right.
Ah, okay. So you added it by hand, right? But okay,
Yes.
let's not do the calculation by hand. Let's delete the answer. Just sort of 155.
Okay.
And also the equal sign. And let's run this and see what happens. Let's see if the program can do it for us.
Okay. Must have white space separating its Okay, so what does this mean?
Okay, so white space is, for our purposes, just space, like space bar. So add space around the plus sign.
Okay. And then run it?
Yep.
Okay. Oh, there we go.
There we go. Okay. So great. So programming is like using a calculator, which is unsurprising because a calculator is a computer, right?
Yes.
Okay. Why don't we add a third number in there and see what happens?
All right. Mm, okay.
Ah, very nice. Okay. So far so good. We can add three numbers. Could we try changing one of the plus sign to a minus? Oh, what's happening here?
Reading this expression errored. Oh, they want me to do it in like with parentheses to put it in order, I'm assuming.
Okay, let's try that.
All right. So I'm not very good at math. I don't remember the order of operations, but I'll put this in parentheses here.
Nice. So yeah, basically, um, it was asking like, okay, do we minus first or do we plus first? You got to tell the program. And so you said, oh, let's minus first, which is why you add parentheses around it first, right?
Yeah.
Okay. It's funny that you say you don't remember the order of operations because the programming language doesn't remember it either. Or not it doesn't remember, it doesn't know it in the first place.
Right.
So in like mathematics, I don't know if you know like BITMAS or PANDAS.
Hmm.
There are six letters, and usually students are asked to memorize them. The thing about programming languages is that there are many more operators. It's going to be more than six letters. We're talking like 20 letters at least.
Hmm.
And it's like really painful to memorize all of them. And in some programming languages, you gotta know them. You gotta memorize them. But this programming language is designed for beginners, and we don't want beginners to suffer. And like memorizing like arbitrary symbols and their order is like pretty painful and like soul crushing. And so that
Yeah.
they don't expect you to do that. And so that isn't actually a convention for order of operations. You have to specify them all the time so that it's clear.
Hmm. That's cool.
Yeah. So it works in your favor here.
Definitely does. So, just a question.
Hmm.
Does learning pure, this is period, I
Oh,
think,
pirate.
parrot, does
Yeah.
it translate to later when I would go to maybe learn C++? plus plus?
To some extent, yes, but this language is designed to transition you into Python.
Okay.
Is that something you're interested in, learning C++?
Yeah. But I mean, I'll learn
Okay.
Python too.
Okay. Because I would say like my recommendation is to like start with this kind of languages first before getting to C++, plus plus, so that by
Okay.
the time you're in C++, plus plus, you're like ready, you're very well prepared.
Yeah, like baby steps.
Exactly, yeah. Okay. So right now, okay, we're using a calculator that does not have conventional order of operations. Yeah, could we try multiplying a number in here? So don't delete anything and multiply a number.
Sure.
Okay. Okay, so you do know it's that symbol. Okay, very good.
Mm. Again, with the order of operations, they want parentheses around something.
Mm-hmm. Yeah, so like in like conventional mathematics, it's assumed that multiplication happens here, but the assumption doesn't exist here.
Yeah.
Very
Okay.
nice. Okay, it looks about right. Okay, so far so good. We're gonna try something a little bit different. Okay, you're gonna need to humor me for a second. This is gonna sound weird, but can you delete everything on the left-hand side?
Okay. Everything on the left?
Yeah. Oh no, like the
Okay.
whole thing.
Okay.
Line two, yeah, yeah. Oh yes, the
Okay.
reason why I say left-hand side is there are two windows. There's one on the
Yeah.
left and the one on the right, right? So yeah, when I say the left-hand side, I'm referring to the left window.
Okay.
Okay. So I'd like you to write two numbers separated by a comma.
Okay. Two numbers separated by a comma.
And then I'd like you to surround them in parentheses. And then before the first parentheses, I'd like you to write a few letters. First, write NUM dash
Dash.
MIN. Yep,
MIN.
yep,
Okay.
like min. Perfect. Now, before we run it, what do you think is going to happen?
Assuming that they're going to well, because min, when I think of min, I think of minimum, so I'm assuming they're gonna find like the minimum number, maybe.
Okay, okay, let's run it. Let's see.
Okay. Yeah.
All right. Why don't we change the 13 to a higher number just to test our hypothesis?
Okay.
Yeah,
Yeah. Okay.
excellent. Okay. Now notice how we're using words here.
Yes.
Now I got a question for you. How many math operations could there theoretically exist?
Uh, gosh, I mean, I feel like there's not a number that you could put on it.
It's like an
Like it's,
infinity, right?
yeah, infinite possibilities.
But there are only a limited number of symbols. Plus, minus, times, divide. We're gonna run out. And so we gotta start using words for math operations, right?
Yeah.
Yeah. Um, so num_min is just one example of that. There are others which we may see in due time. There is like a reference or a dictionary of these functions, this word math operations that we can use, uh,
Okay.
which we'll explore in the future. All right, but for now, let's keep going with this. Could you add, so don't delete anything. Could you add this whole thing to another number?
Okay. So add another number into these parentheses or at
Or,
like,
okay, you can actually do both, but let's do outside first.
okay.
Yeah.
Like that?
Yep,
Okay.
perfect. Okay, great. So the same way we can do like plus and minus on one line, we can also do plus and like a different math or word math operation on the same line.
Right.
So the fact that it's a word operation isn't really significant. It's still a math operation at the end of the day, right?
Yeah.
Okay. Could you move the plus 45 inside the parentheses next to the
Sure.
23? Yeah. Okay, same thing, right?
Hmm.
There is a difference, and you just got to trust me on this because you can't see the difference, but the addition is happening before the minimum operation here.
Okay.
Whereas beforehand, the minimum operation happens before the addition.
Because it's in the parentheses, so it has to be done first.
Yeah, because the minimum is like, oh, okay, we need to compare two numbers. Oh, the second one's the sum. We need to compute the sum first to figure out what that number is.
Yeah. Huh. Okay, that's interesting.
Yeah. So again, repeating this idea of order of operations, but now with worded math operations. Okay, by the way, when I say worded math operations, I just mean functions. So
Okay.
I'm going to use the word function from now on. It's much shorter. Okay.
All right.
Uh, so right now we have basically explored the laws of arithmetic, and so far we have been using this like a calculator, and we are going to move forward in time a little, and we're going to explore the laws of algebra. Could we delete everything in the left window?
Yes.
And I would like you to write x equals 1, and then on a new line, x.
Oops. So let me do a few different
Okay.
lines.
Now, before we run this, what do you think is going to happen?
Um, I mean, I'm assuming it's just gonna equal out to one because x equals one.
Okay, let's run it.
Yeah, okay.
Okay. So this is like variable substitution, right? Whenever we see x, we see 1.
Mm-hmm.
Okay. Could we do change x into x plus 1?
Yeah.
Oh no, sorry, I meant line 3.
Oh, okay.
So
All right.
x equals 1, and then on line 3, x plus 1.
Yeah, hold on. Let me just edit that really quick.
Hmm. And then you can delete line 3. Oh yeah, yeah, this works too. Okay, so we can mix variables and numbers, right?
Yeah,
Yeah. Okay, so that's the takeaway from this. And so yeah, we have basic algebra. We can use variables now.
that's cool. Okay, cool. That makes sense.
Yeah. Okay, let's do something funky. Can we change line 3 to x equals 2?
Sure.
Now,
And delete
before we
line
run
one.
this, yeah, keep all of them now.
Okay.
That's perfect. And before we run this, what do you think is going to happen?
Well, I don't know, honestly. I'm assuming that maybe this obviously the output will be a little bit different because now that we've changed the variable, but the other variable still exists. So I'm unsure what's gonna happen. Maybe they're gonna add to each other. I don't know.
Okay. All right, let's run it. Let's see what happens. Oh,
Doesn't work.
the declaration of a name conflicts with an earlier declaration of the same name. Okay.
So we have to delete
So
one of these.
exactly, you could only have one. So note in all different programming languages will do this differently. In this programming language, it's an error. And uh, one justification for this is that if we are a mathematician and we write let x be 1, let x be 2, x plus 1, that's kind of weird, right? Why do we say let x be 1 in the first place?
If you're gonna change it to two.
Exactly, yeah. So again, this is one way of understanding things. We so the term here is declaration. When we say like let x be 1 for the first time, we're saying we're declaring a variable.
Hmm.
Yeah. And we can only declare a variable of a unique name. We can only declare it once. Because like once you declare it, it's like you've declared it. It's like, the Declaration of Independence. Once you've declared it, you declared it. You
Yeah,
wouldn't do
you've
it
already
again.
said it, so you can't really change it.
Exactly. Okay. Let's try something different. Can we delete line 3?
Sure.
Okay. I'd like you to swap the order of the two lines. So x equals 1 to be placed after x plus 1.
Okay.
All right, let's run it.
The name is the name X is unbound. It used to be, well, it is used but not previously defined. So it can't run it because you never defined it in the first place. So you have to do it before you run the equation.
Exactly. So there's a notion of time here, right? We're able to say the definition hasn't happened yet. We're on line
Yeah,
two, the definition happens on line four, but we're still on line two.
yeah.
So what I said about order of operations, that also applies to multiple lines,
Hmm.
across multiple lines. Yeah.
You
Um,
can't have one thing if you don't do the other.
exactly. Like if this was like in reverse, it would work, but it is not. We go from top to bottom in this language,
Hmm.
so this doesn't work. Okay, cool. So we've covered variable substitution again for going through the laws of algebra. Let's uh let's explore a new idea. Another idea of the mathematics we do when we learn algebra. We're gonna look into functions now.
Okay.
Um, let's delete everything again, and we're gonna define a function. So this is gonna sound funny, so I need you to humor me for a second. First, you gotta write fun, fun. So notice how it's bolded. It's a keyword. We're telling the programming language we're defining a function, right?
Okay.
So we're going to define the function f of x equals x plus 1.
So,
So let's oh, not yet. Let's delete that and let's space.
okay.
Yeah, space.
Oh, space. Okay, I'm
Yeah.
sorry.
That's okay. Letter F, opening parentheses.
Okay. Oh, F first and then the parentheses?
Yep. And
Okay.
then x, closing parentheses, colon.
Okay. Colon, you said? I'm sorry?
Yep.
Okay.
New line. X plus 1, new line. E and D.
END, end.
Yep.
Okay.
All right. Notice how it's all highlighted now.
Mm-hmm.
So the language was like, oh, you've just defined a function. Now let's run this and see what happens. Okay, nothing happens for now.
Nothing.
So all we have done is we have defined a function, but we haven't used it, so there's no values, right?
Right.
Okay. So a f- so something about functions. What is a function?
Um, well, to put it simplest, it's something that has to work. It functions. I don't know.
Okay.
I'm not the best with math.
Okay. You're on the right track. It definitely is doing something. It's doing some kind of work.
Hmm.
Um, so another way of understanding functions is that it goes from input to output.
Okay.
You give it something, it gives you something back.
Hmm.
So in this case, we give it a number, it adds one to that number and gives you back a new number, right?
Okay. Uh-huh.
Okay. So there are three parts to a function. First, there's the name. This function is called f. It needs a name so that you can refer to it.
Yeah.
The second part to the function is the inputs. What can you give this function? In this case, you can give this function one thing.
Okay. X
Okay.
plus one.
That's the last thing, what it does. So this is the functioning part of the function. Like, in what way is it functioning? So in here, whatever you give it is going to add one to it. It's going to spit it out.
Okay.
We call the third part, like the function part, or like the thing that's actually doing work, we call it the body of the function.
Right.
So it's the name, inputs, and body. For
Yeah, okay, that makes
inputs,
sense.
you
Hmm.
might also hear the word parameters. In fact, that's actually the term people use, parameters. So like when people say parameters of the function, it's the inputs of the function,
Right.
which in this case is x. Okay.
Okay.
And yeah, let's and the e and d, the end is denotes the end of the function. So if you don't write that, the programming language does not know when the function actually ends. So it's
Okay.
important to write that. Okay. All right, let's actually use this function. So in mathematical speak, we say we apply a function, but
Hmm.
in programming, we say we call a function.
Okay.
All right, to call a function, okay, first let's go back to the left window and let's create a new line. First, we need to know what functions, and we need to refer it by name. So let's say we want to call f, let's write f.
Hmm.
Next, opening parentheses. And now any number you want.
Okay.
13, great. And then closing parentheses. Okay, now we can hit run.
14.
Nice. So yeah, we are calling a function. So we're passing 13 into the function. The x becomes 13. 13 plus 1 is 14, right?
Yeah.
So there's a notion of variable substitution happening here, right?
Right.
But notice how we never said x equals 13. We never said that.
No,
But yeah,
because we just named, we all we had to do was, like you said, variable substitution, right?
yes. Yeah. Okay. So yeah, that's a function, and that's how we call a function. Uh, Notice how there are two windows, and we've been typing the left window.
Yeah,
Okay, I want to explore the right window. So the right window has been giving us answers.
the output.
Wait, notice how there's like a text box there, like you can type stuff in it.
Hmm.
Can we call the function here as well? So let's do f opening parentheses and a different number. And then closing parentheses, and then do not hit run, hit enter. Ah,
Hmm. So
okay.
it's like
So
this is the setup and this is like the continuation almost.
yes, yes, actually, that's perfect. That's a perfect understanding of it. So just some vocabulary. The left window is called the definitions window, or you might
Okay.
hear definitions pane, like pane on the window.
Hmm.
Um, I'm just going to use the word window for our purposes. So this is where we define our program. This is our actual program. And
Okay.
the right-hand side, we call it the REPL, REPL. So the four letters, R for read, it reads what you write. So it's
Hmm.
going to read, when you write F28, it's going to read that. E for evaluate, evaluate meaning make a value. It's going to take your F28 and it's going to simplify. So for our purposes, evaluating is like simplifying.
Okay.
It takes your F28 and then simplifies as much as possible. So 28 becomes, F of 28 becomes 28 plus 1, which becomes 29. So that's the final answer. The P stands for print. It prints the answer. And L is loop. It allows you to do this again and again. So read, evaluate, print, loop.
Read, evaluate, print, loop.
You don't really need to know this, but just like when I say REPL, you're like, oh, that's what he's referring to.
Okay. All right.
Okay, so not all languages have this. This is like a nice thing about certain languages, and this language is designed for beginners, and an important thing for beginners is that there's fast feedback, and REPL gives you very fast feedback, which is why they implemented this feature.
Okay. That's cool.
Yeah. And you can do all sorts of things. You can do like 1 plus 1 here, and if you hit enter, it'll give you the answer immediately.
Can I do it here on this side?
Yeah. So like just add any numbers. Oh, don't run, don't you run.
Oop.
You're gonna hit enter.
I'm sorry.
No, it's okay. But that's a very common thing, yeah. So
Oh
if you
man, I
add
gotta
any
get
two
used to
numbers and
that.
then hit enter,
Okay.
yeah.
Oh, I forgot to put a space in between.
But it's like once you've written it down and hit enter, it's like carved in stone. You have to write a new line.
Oh man. Okay.
Yeah.
Well, that's annoying. Oh, now it won't let me write anymore. All right, hold on.
Yeah.
Okay.
Nice.
Okay.
Okay. Notice how clicking run refreshes the REPL.
Hmm.
Okay, so notice how the REPL you can also use definitions from the definitions window, like the function f, the
Yeah.
name f, it knows what it is. So when you hit run, it like passes on all the definitions from the left-hand side to the right-hand side. And the reason why it refreshes everything on the right is so that I think that's like an ergonomic thing. It gives you the idea you have rerun your program and the definitions are now new.
Yeah, like
Yeah,
it's restarted.
exactly. Yeah. Okay. So to summarize what has happened so far, we have basically used this like a calculator and we have explored arithmetic and then algebra. We have covered variable substitution and functions, defining functions and using functions.
Okay.
Okay. Let's so all this is like the mechanical parts of programming, but I would say there is a huge layer to programming that they don't usually teach you. in traditional computer science courses. Uh, so I'm about to say something that's like pretty philosophical, but it's also a very practical idea, and you gotta humor me for a second. Um,
Okay.
so first, I want you to delete everything on the definitions window, and I'd like you to write the number 5, and then run. Okay, so I got a question for you. What does
Okay.
5 mean?
Um, five means five. There's
5 means
no,
5.
there's nothing defining it. So I mean, five is just five.
Okay. Now let me change the question a little bit. What if I say 5 degree Fahrenheit?
Okay, well then it's 5 degrees. It's cold.
Okay. It's very, very cold. Yeah. Okay. So now it's how hot, how cold something is. It means something a bit more. How about 5 kilograms?
Um, it's light. It's lightweight. It's the weight
Okay.
of it.
Okay. How heavy, how light something is. No,
Hmm.
but they're all 5, but depending on whether or not I say Fahrenheit or kilograms, it means something a little different, right?
Yeah.
Okay. So there are two worlds. There is the world of information. So this is facts and ideas about the real world.
Hmm.
And there's the world of data. This is what the computer sees. Now, when we say 5 degree Fahrenheit, we know we're referring to temperature, how hot or cold something is. But the computer,
Hmm.
all it sees is 5. It sees the text in front of you, that number 5. Okay?
Hmm. Yeah.
And my claim is that our role as programmers is to translate between these two worlds, to convert to convert information into data and data back into information.
Okay. Like the middleman.
Exactly. Yeah. And for example, like an electronic thermostat, the electronic
Hmm.
thermostat is going to take readings from the natural environment, like electrical resistance, molecules in the air, and whatnot. And it's going to get a bunch of numbers. And the computer inside of it is going to get all of these numbers. It's going to perform math operations and it's going to reduce all of them into one number, the temperature. But it doesn't know it's the temperature. It just performs math operation and gets a number. And then it's going to display it. We'll see 5 degree Fahrenheit. And now, oh, 5 degree Fahrenheit. It's pretty cold. It's that data, that number becomes back into information when we read it. Yeah?
Right.
Hmm. Okay.
Okay.
Uh, so just to reframe everything we have done so far, what we've been doing is we have been encoding information as numbers and performing operations on those numbers. Okay. I got a
Okay.
somewhat philosophical question. Can we
Okay.
encode all information as numbers?
Um, I, f- I feel like maybe, but I don't think numbers can really define everything.
Okay. Now I got a counter argument. Have you ever heard that computers are a bunch of zeros and ones?
Yeah.
Okay, so we can define everything as just numbers, right? If computers are just zeros and ones.
Okay. Yeah, I suppose so.
Okay. So theoretically speaking, we could encode everything as numbers. But the next question is, do we want to?
No,
Why not?
because I mean, I feel like it things are not as simple as just a bunch of zeros and ones. I feel like there's more to things. There's information in between. Like it can't be put so plainly. It can't be all black and white.
Hmm. Okay. Yeah, and like, for example, we are communicating right now. As we
Hmm.
speak with our words, we're transmitting information to each other, but we're not speaking in numbers. We're
No.
speaking with words, right?
Yeah. It's like if we
Um,
all used Morse code for everything. It's too
exactly. Yeah,
complicated.
exactly. You know, I actually used an example like we're not speaking in Morse code. I usually say that, but you took those words right out of my mouth. Yeah.
Yeah.
Um, but you know how they say like the universe is just a bunch of particles?
Hmm.
Like, for example, there's a table in front of me. But in the eyes of the universe, it's just a bunch of particles, no different from anything else. But when I
Suppose
see
so,
this
yeah.
table, I see a table.
Exactly.
So there's a whole other dimension to this, which is that we think in terms of how we think. Sure, something may be made of numbers, but we see something more than that. Yeah.
Yeah.
Okay. So I'm going to introduce a new way to encode information that is very useful, that numbers don't do justice to. Could you delete that five?
Sure.
And let's write double quotes. Hello, comma, space world, closing double quotes. And let's run it. Ta-da! We
Yeah.
did not get a number. That is not a number. That is something, that's a whole different animal. Fact, that is a string. We call it a string because I guess it's a string of characters. I don't know why they call it that. It's a string.
Yeah.
So a string is used to encode like words, text. Yeah.
Yes.
So this hello world example is it's like a rite of passage for programmers. It's that's history behind it. I believe it's in the 70s. There's a one of the first few programming books. It used this example, hello comma space world. And ever since that day, every book, every tutorial, every video course, lecture uses this example. It's a rite of passage. So you have
Okay.
just crossed a very important milestone in your life. Okay,
Cool.
so okay, this Zoom session is gonna expire because I'm on the free tier. I'm gonna close this one and send you a new link. So check your email and I'll see you in a minute.
Okay.
All right. Oh, there we. Yep, I can see it now. All right. So
Okay.
we have a string. Just now, we have numbers and we were able to perform arithmetic on numbers. Now, could we perform arithmetic on strings? Can you try adding this string to another string?
So another line.
Oh, all in the same line.
Okay.
Yeah.
What should I add?
Oh, so you want to go past the double quotes?
Okay.
Yeah, and then a plus sign, and then a double quotes, and then any text you want.
I don't know.
Okay, perfect. Let's run it. Let's see what happens.
Space. Okay.
Mhm.
So I suppose I should probably do that for everything going forward then.
Oh yeah. If you forget, it'll tell you. Don't worry. Okay,
Hmm.
nice. So the same way we can add two numbers, we can add two strings. So we sort of
Cool.
we're sort of moving beyond a calculator, right? We're no longer just operating with numbers. We're operating with strings now, and we can add
Yeah.
two strings. Could we try changing the plus sign to a minus?
Sure.
Okay, let's run it. Let's see what happens. Oh,
Hmm.
the minus operator expects to be given two numbers. Doesn't work with strings.
Yeah, it doesn't make any sense for it to work with strings, I guess.
Guess it wouldn't, right? Hmm,
Yeah. You just delete the second string if you don't want it there.
exactly. Okay, so we can do arithmetic with strings, but it looks arithmetic with strings looks very different than arithmetic with numbers.
Hmm.
Okay. All right, let's delete everything. And I got another somewhat philosophical question again. Could you write
Okay.
double quotes and then the number five
Double quotes and then the number 5.
and then closing double quotes? And let's run this. Okay, nothing surprising, right? The same way we can write hello world in string, we can also write the number five in string.
Yeah.
All right, could we create a new line and then write the number five, not in quotes, just regular number five, and let's run it again. Okay, so here we have two instances of five, one in strings, one that's just a regular number. Okay, so here's my question. Now that we have strings, and strings are a series of characters, and in order to write a number, we need to write a series of characters. Why do we need numbers? Why not just use strings for everything?
Um, Good question. I mean, I know this is not very descriptive, but I guess it's not the same.
Hmm.
Because I
In what way
mean,
are they not the same?
yeah, I mean, one's a string and one's numerical. They're both numbers, but one's I don't know. It's different. It's a difference to it.
What's an example of a difference?
Um, well, I guess I don't know. I don't know. You got me a little bit stumped there.
Okay, you're on the right track. So let's frame this differently. What we can say is they represent the same piece of information,
Hmm.
but their representation is different.
Okay, yeah.
And in what way are they different? They're different operationally. You can do different stuff with them.
Yeah.
For example, we can minus two regular numbers, but we can't minus two strings.
Yeah. They don't, yeah, it doesn't serve the same purpose.
Yeah. So while the same piece of information can be represented with multiple data types, so when I say data type, I'm referring to a classification of data. So a
Hmm.
number is a data type, a string is a data type. So we can represent the same piece of information with multiple data types, but there are strengths and weaknesses to each.
Okay,
And
yeah.
part of our job as programmers is to determine what's a good representation for any given piece of information.
Okay.
Yeah. Okay. So to summarize, we have covered two data types. We've covered numbers and strings, and we saw that we can perform arithmetic with them.
Yeah.
All right. Let's move on to a different data type. So far, data type seems to be like encoding some piece of information in some very fundamental way, right? Numbers with, numbers, it's the whole field of mathematics. We have strings for words. Now, there's a third idea that's also very fundamental, and that's the idea of decisions. It can be said that life is a series of decisions. What is a decision? A decision is fundamentally yes or no. For example, your decision to come to this office hour must have said yes.
Yeah.
The idea of yes or no is very fundamental, like yes, no, on, off, right or wrong, true or false, this idea of duality. And like our computer, it runs on this idea of duality. Um, so in programming, we use true and false,
Okay,
and we
yeah.
call them booleans, named after George Boole, a mathematician who studied these as mathematical objects. So, okay, can we change line two and change it to true? Sorry, can we delete everything and just write true, TRUE? And let's run it. True. You get back true. So true is a value in this programming language.
Okay.
Notice how it's red in color as well. It's special.
Yeah.
Can we change the true into false? FALSE.
Typo.
Mhm. Very nice. Again, red in color, and we get back a value, true and false. Okay. Uh, so this is a new data type, booleans, used to encode decisions. It's a which is very important for computers because computers are all about making decisions.
Hmm.
Now, let's can we write false and true? So that's false A and D true. So notice how the and is bolded. It's
Yeah.
special. So let's run it. Okay. So we have two booleans and we merge them into one. So there's some kind of arithmetic happening for booleans here. Could we change the A and D into or?
Okay.
Okay, so again it's bolded. Let's run it. Now we get true. False or true is true. Again, another form of arithmetic for booleans. Now we call the middle term, the bolded term, Boolean operators. That is, they're operators for Booleans.
Okay.
So the same way we can do arithmetic on numbers, arithmetic on strings, we can do arithmetic for Booleans. Okay.
Okay.
So why is it that false or true is true and false and true is false? It's all false and true is happening. I'm gonna share my screen real quick just to show you what they are. One
Okay.
second. And you can keep sharing
Yes.
yours. I'll be sharing mine just for a split second. Okay. I've just shared my screen. Let me know once you can see it.
Okay, I can see it.
Great. Okay, so here we have truth tables. So this gives us answers to our Boolean arithmetic. So for example, false and true is false. So this is the AND table. This is the answers for the AND. False is 0, 1 is true. False and true is false. That's the answer here. For the OR table, false or true is true. remember how I said like computers are a bunch of zeros and ones?
Hmm.
These are the zeros and ones. These are it.
Okay.
And these things above the tables, these are logic gates.
Okay.
These are things that take electrical signals and produce more electrical signals. These are functions. They take in electrical signals and they
Hmm.
produce another electrical signal. These ones give me 2 booleans, I give you 1 boolean back.
Yeah.
Yeah. And so our computers are made with thousands, millions, billions, trillions of these things. Remember how like life is a series of decisions? Computers are all about making decisions. These are decisions. These gates, these functions, they make decisions. Like
Okay.
0 and 1 is 0, that's a decision. We have like trillions of these decisions, and we
Hmm.
can create amazing things such as our computers.
Right. Okay.
And so like back to the idea of can we encode everything as numbers? So like just the same way our universe is a soup of particles, computers are just a soup of zeros and ones, and these logic gates are like mixing the soup. They're turning zeros and ones into different zeros and ones, and that's what makes
Hmm.
computation possible.
Hmm.
Yeah.
Okay.
So you don't really need to know all of these. As a programmer, you need to know now not, which flips false to true, true to false, and or. These three.
Okay.
The rest are like you don't really need to know them, and they're like for electrical engineers and cybersecurity if you're into that.
Okay.
Um, so as to like why is and or like that, the short answer is that's just the way it is. That's how it's defined, and they happen to name it that. But the more nuanced answer is that intuitively, is that if I ask you, do you have an apple and a banana, but you only have a banana, you're gonna say no, I only have a banana. I don't have both of them, so it'll be
Yeah.
false. But if you have an apple, so if you have a banana, only a banana, and I ask, do you have an apple or a banana? You'll say yes, I have a banana. I have one of them. So
Hmm.
it's yes, true. So that's the intuition behind these names.
Okay. That makes a little bit more sense.
Yeah.
Is
Of a
there
mo Yep.
sorry. Is there like a better way to like study these like particularly just to make sure that they stick?
I'll tell you in the mnemonic. So for okay, not is obvious, I think. Not is just flips it. For and, if there is a false, it's false. So notice if there's a zero in one of these rows, the output is a zero.
Okay.
If for or, if there's anything that's true, it's true.
Okay, that's easy. All right.
Yeah. So I told you it's a mnemonic. You don't even have to memorize it. It's in your head now. You remember it forever.
Yeah. It just looks a
But
little intimidating.
oh yeah, yeah. It's because there's a bunch of information here. Um, yeah, that's it. I think that's it for Boolean operators. And also, like a lot of these, it comes with time. Like it'll be part of you. Like once you write one or two of these, it's gonna you're gonna remember it for life, no matter how
Yeah.
much you try to forget it. Okay,
Hmm. Okay.
okay, great. I'm gonna stop sharing now. And so your Boolean operators. So that's the third data type, Booleans. So just to
Okay.
summarize, we've covered numbers, strings, and Booleans and how quote unquote arithmetic appears for each of them. These three
Yeah.
things, number strings and booleans, they're like cash. If you're lost in a city, but you got cash, you can probably get what you need.
Yeah.
So if you have a piece of information and you want to encode it, you want to represent it, chances are you're going to use one or more of numbers, strings, or booleans.
Those are
Okay,
the basics.
exactly. They're like the building blocks of our programs. Okay, I'm going to uh send something on Zoom chat, and I'd like you to paste it in.
Okay.
Give me 1 second, let me find it. I found it. Okay. Okay, I've just pasted in something to Zoom chat. If you could copy that and paste it into the definitions window, just replace
Okay.
whatever is there. And don't run it yet. Okay, now don't run it. What do you think is going to happen when we run it?
Okay, so it says circle 30, then it says solid red. Well, I'm assuming since this is a string and since this is a numerical, it's going to be separate on two different lines. And I don't know. I mean, honestly, I'm just I'm ready to see what it does.
Okay, just give a guess. Just any guess. Any
Mm,
guess will do.
maybe it's gonna circle something.
It's gonna circle something.
Yeah, because
Like
it says circle.
like visually, like something like you will see a circle.
Maybe.
Okay. All right, let's run it.
Oh, it's just a red
Ta-da!
circle.
Yeah.
Okay. So what does the
So
30 have to do?
let's change the 30. Change the 30 and see what happens.
Okay. Oh, it just changes the size. Okay.
Size, yeah. Okay. So this is a function. You give it properties over circle, like what the size, is it solid or not? What is its color? You give it all these properties, and it gives you
Hmm.
back a circle with the
Okay.
properties. And not just any circle, it gives you back an image. I've
Yeah.
introduced three data types so far. There is a fourth one. This is the fourth one. The fourth data type is an image. We can encode information as images,
That's
right?
cool. Yeah.
Yeah, yeah. Okay. So a data type doesn't have to be fundamentally philosophical. There's no existential reason why it needs to exist. Sometimes they're just useful. So this language is designed for beginners, and oftentimes beginners are children. And so, working with images is fun. It's very engaging, and that's why
Yeah.
images is a key part of this language. It's a data type here. In other programming languages, it probably saves an image to your file system. You won't be able to run it and see an image right in front of you.
Hmm.
So this is a very cool feature here. Okay. We have some time left, actually. I think we can take this further. Okay, so the same way we can do arithmetic with numbers, strings, and booleans, we can do arithmetic with images.
Yeah.
So, okay, okay, how do I want to do this? This is this is the less intuitive part. Okay, okay, I'm gonna send you some code over in Zoom chat. I want you to paste it in, and it's very rare that I'm gonna send you code for you to paste in. But
Okay.
this is just for starting out. So I pasted in some code. Could you copy that and paste it?
Yes.
Yeah,
And then the second line.
yeah. You should be able to copy multiple lines.
With these spaces in between at the top?
Yeah,
Okay.
it should work. Let's see. Okay. Okay, great.
Okay.
Let's
So
run
run
it.
it.
Yep.
Okay. Oh, that's cool.
Ta-da. So we are combining images. This is a form of arithmetic for images.
Okay. How do they know which one to put on top?
Okay. So it depends on what the so this function, like a human being wrote this function overlay.
Hmm.
Like,
Okay.
why is the circle on top of the rectangle? That's just the way they wrote it. That's how they implemented the function.
Okay.
In theory, someone could make a different function that puts the rectangle on top of the circle.
Right.
So in this case, order is what determines the which goes on top.
Okay.
Okay, I'm gonna send another piece of code for you to see. All right, oh wait. What the... Okay, there we go. I just sent it.
Okay. Should I delete this first?
Oh yeah, sure. All right, let's run it. Ta-da!
Okay.
So this is a different way that images can combine. Just now you saw one image on top of the other. Well, okay,
Well, they both are.
okay, they're both on top, but like they're different ideas on top, right?
Hmm.
One's overlaid and one is like, okay, it's hard to describe, but you can see it, right? This is why we
One's
work with
above them
images,
and
you can
one's
see it.
overlaid.
Yeah, exactly, yeah. Okay, so that's different forms of arithmetic.
Okay.
Okay, um, okay, I think we are running out of time, so I'm not gonna take this further, but I will show you one thing. you're probably wondering like, okay, how do I know what all these functions are? Like, what are all the different ways that images can combine?
Hmm.
So the same, like when you're learning a language, chances are you'll use a dictionary to see words that you don't know. But
Yes.
when learning a language, you're not going to read the dictionary from A to Z, right?
Mm-mm.
You use it as a reference when you need it on an on-needed basis.
Like an index, kind of.
Exactly. And the same thing is true for programming languages. So I'm just going to send this to you on Zoom chat. This is sort of a dictionary for the image component of this language.
Oh, great. Thank you.
Yeah. So if you're curious and you want to play around with this, you can look into this dictionary and see what ways that images can combine. Okay, okay, could you scroll down to one of the functions just so I could show you how to read this dictionary?
Okay, sure. Should I just click one off the side here?
Oh, wait, could you scroll on the right-hand side? So,
Okay.
yeah. Okay, yeah, let's scroll into color name. Okay, this will do for now. Okay, so remember how I said a function has like three parts?
Hmm.
Name of a function, inputs and outputs.
Yes.
Okay, in this case here, the you cannot see the body of the function.
Right.
But if you think about it, you don't really need to know the body of the function. A function is input to output. You don't need to know what it does inside.
Hmm.
So basically, what this dictionary tells you is what's the name of the function? What can you pass in? What are its inputs?
Hmm.
It tells you like, and what does it output? So there are two layers to this. The first is what does the computer understand? So the computer understands, so for color name, it takes in a string and produces a color. So these are data types.
Yeah.
Oh, color is another data type. Okay, we'll get to that. But if you look at the description below that, these are human understandable context. What does the name mean? Oh, name means colors, colors of names.
Yeah.
Yeah.
Hmm.
So, okay, so this is how you use this dictionary. And if you look at the top left, that's search manuals. So if you have something in mind, like for example, overlay, what does overlay do? You can search for it. You don't have to flip through pages. You just type overlay and it just gives it to you. Ta-da.
Okay.
Okay.
Cool. Cool.
Okay.
And then it just
So
tells you.
yeah, okay. So we are running out of time, so I'm gonna start wrapping up. One thing I like to end the sessions with my students is I like to ask them, what's one thing you learned today that stuck with you?
Um, Definitely, I think what stuck the most is the number minimums. I can remember that the most.
Oh, cool. Okay.
Yeah.
Okay. All right. So we are at the end of our session. Uh, I don't give homework unless you want homework, in which case I'll give you a lot of homework. Uh,
Okay.
yeah. Okay. Do you have any questions, closing thoughts, anything?
Um, so is just are the manuals just an easy way for everybody to remember every little piece of it? Because I feel like when it comes to programming languages, there's so much to remember that I feel like is it possible for somebody to remember all of that from the top of their head?
No, it's more like a reference. It's sort of like, oh, I need to like put these two images on top of another. Oh, it's called overlay. Okay, let me search up overlay. Oh, so that's what it does. It's like
Okay.
more like a reference. It's like similar to a dictionary to when you're learning a natural language.
Yeah. Does anybody ever know it by heart?
When you work with something for a long enough time, you will remember it by heart.
Okay.
Yeah.
All right. Well, that's all the questions I have. Thank you.
All right, no problem. All right. Thanks you for joining me, and I'm very happy to help you on your journey, and I hope to see you again.
Okay, for sure.
All
All
right.
right.
Bye bye now.
Bye-bye.